Okay, friends. So this is a video on Gauss law for electrostatics. Uh, Gauss law, if you see, basically it is defined as uh, total electric flux is given by E dot or E dot surface area we say, surface area. Surface area of a sphere, for example, if you are talking about a spherical charge distribution, sorry, a spherical surface, say a conducting spherical surface, and the charges are on the surface. Because, for example, if you take a copper ball, inside the ball you cannot have charges because you cannot have independent charge inside a metal. So the charges are always on the surface. So the charges are on the surface. So the surface area of the sphere is 4 pi r square, and electric field is say q by 4 pi epsilon r square dot 4 pi r square. So the final this thing will be charge by epsilon. This is one way of defining Gauss law, or otherwise you can say uh, another way of saying is d dot ds. That is, d is the electric flux density. Already d is just electric flux density, that is q by density means charge divided by surface area of the sphere, and total this thing 4 pi r square, and the surface area of the sphere is again 4 pi r square. So you can say it is just q. You can put it like this. So here the flux is just q. Either way, the idea is flux is in some cases we are just interested in saying d dot ds. In most cases we are interested in saying e dot ds. We will take couple of problems and see how this one works. See, this problem we will see. We are talking about concentric spherical shells, one over the other with the center at the origin. For example, 2 meters, 4 meters, 8 meters, carrying uniform charge densities. So you can visualize this as 3 concentric shells, and they are saying that charge density, that is the, look at the unit, it is nanocoulomb per meter square. So it is, they are talking about d. D unit is charge per meter square, because we said that q divided by 4 pi r square. So it is nanocoulomb per this thing, so they are talking about d. Of course the magnitude, they have not given any direction. So this is the 2 meters, and the charge on this is, let us say this is q1, q2, q3. The question they have asked is, if you try to enclose a 10 meter this thing, say this is, say what is this distance, say 4, and this is say 8, they are saying enclose a big 10 meter this thing, there the electric flux, whatever flux coming here should be 0, they are saying. Electric flux should be 0 means whatever charges inside, when will the electric flux be 0? If you take 5 coulombs of plus charge, for example, if you take minus 5 coulombs of minus charge, if you enclose this thing, the total flux coming out of this will be 0. To get the flux coming out of this one 0, the total charge inside the region should be same, that is the plus charge should be same as minus, or you can say the net charge should be 0, whatever you understand. So the q1 plus q2 plus q3 should be 0. That is the first observation. q1 plus q2 plus q3 should be 0. How do you get charge? When charge density is given, you should multiply by the surface area of this thing. So you can say that they have given that q1, two numbers are given. They have said that q1 is 20, q2 is minus 4, and they are asking what is this answer, q3. How to attempt this one? This is not charge, by the way, this is d. I made a mistake. This is D. How do you get Q from this? D into surface area of the sphere. Charge is D into surface area of the sphere. So you can say that 20 into 4 pi r1 square plus minus 4 into, see this nanocoulomb is there, 10 power minus 9. Since other side is 0, I am just skipping it. If you say rho 3, charge density means we usually say that rho 3 or D3, whatever you want to call it, 4 pi r3 square equal to 0. So it is final answer if you try to calculate. D3 flux density is minus 0.25 nanocoulomb per meter square. If you substitute R1, R2, R3 values, you will get this. The idea is the total flux coming out of this one should be 0. Flux is 0 means the charge inside should be, net charge should be 0, or you can say the plus charge should be equal to the minus charge. Alright, another problem. Here what they have said is, they are asking what is the electric flux. Here they are asking electric flux is not D dot ds, they are saying E dot ds they have said. dA means area, ds, dA all mean the same. So here they have explicitly said that flux is E dot ds, and what will be the final answer? They are asking what will be the final answer. What is the total flux of a smaller area? Instead of a total, they have a line charge here, and they have given charge density Q. Q is not the total charge, it is the charge density. So you should multiply that with the total length of the line charge, only then you will get total charge. Q into length. So Q is the charge density for the line charge. And they are asking what is the electric flux in quarter of a cylinder, not a full cylinder enclosing this line charge. It is a quarter of a cylinder they are saying. How do you attempt this one? First understanding is they are interested in flux, that is E dot ds they are interested in, not D dot ds. If you want E dot ds, first you need to know what is the E for the line charge. The line charge, what is E? For the line charge, I understand like this, just to give you a short introduction for that. If you have a bulb charge, if you have a bulb, incandescent bulb, the energy gets radiated in all the directions like a circle. So in that case, electric field is Q divided by, epsilon is there of course, 4 pi r square. If you have a tube light, if you have a tube light, the energy is emitted in the circles around a cylinder. So the electric field here will be, that is line charge. This is a point charge, this is a line charge. For a line charge, charge divided by epsilon is there of course. Then what is the surface area of the cylinder? 2 pi into radius. Radius is usually rho here, and then the length, height, you can say the length. So this is the surface area of the cylinder, that is this circumference of the circle and the length. And if you want a plane charge, that is a ceiling light, the electric field coming out of a plane charge or a ceiling light is, electric field falls by nothing, actually it's a constant. So the idea here is, initially we had incandescent bulb, the energy falls more sooner as you walk away from the charge. As you walk away from the charge, the energy falls sooner because E is proportional to 1 by r square. But for a tube light, the energy falls a little slower. The radius, that is E is proportional to 1 by radius, this distance radius, 1 by rho. But if you have a ceiling light, the electric field is same. For example, if you are using, for whatever distance, electric field will be same. If you keep your book here and study, and or here and study, you will receive the same amount of the light. That's the meaning of this. So that is why we are these days interested in the ceiling lights instead of the bulb or a tube light. Anyways, here the line charge electric field equation will be total charge divided by epsilon is there of course, and the surface area of the cylinder, that is 2 pi radius length. Total charge is, we know the charge density is given, q is not the total charge, charge density they have said in the question, into length is the total charge divided by 2 pi rho L. So L will get cancelled, so the electric field will be q by 2 pi radius. Of course, the direction of the electric field will be outward towards the radius, so it will be like this. This is not a dot product vector. This is the magnitude and this is the direction for this vector. Okay, now we are interested in finding what is the ds for the cylindrical coordinates. What will be the ds for the cylindrical coordinates? It will be rho d phi dz. So if you try to substitute it there, the limits for that dz is, they have said the height is, the limits for z is 0 to h, and the limits for phi is 0 to pi by 2, because quarter of a cylinder, total cylinder circumference is 2 pi, quarter is pi by 2. So if you substitute this, E is charge divided by 2 pi rho, rho d phi dz, rho will get cancelled, q by 2 pi, 0 to pi by 2, z is 0 to h. So it will be q by 2 pi into pi by 2 into h, hq divided by 4. Sorry, I missed epsilon everywhere. Epsilon is a must.